Yeah, good evening, everyone. Shall again? So let's start off. Yeah, comes on everyone. Hope everyone has gone through the notes. Let's start off with a question. Kinetic energy of a particle. Going in a circle of radius r is given by k is equal to b s square. K is kinetic energy, b is some constant, s is the distance traveled. Find the net acceleration as function of s. Get it? It's an easy one. Find the net acceleration as function of distance traveled. Mass of the body is m. ds by m near Anika. That's not the answer. I asked you for net acceleration. Root b by m. Ask me for net acceleration. Remember, net acceleration is what? A tangential square plus a centripetal square. Let's see. This week our test is kinematics, NLM, friction, advanced paper. So do prepare well, revise the notes. Again, I'm telling you, if you guys are not scoring 50% in the exams, there is something really wrong with the way you're preparing. I'm not asking for 90% or 80%. 50% you're not able to get. You guys are not solving properly, you're not revising on daily basis. That's the problem. Let's see. How to do this thing. Do check out the paper, resolve it. I posted the paper also. I think the solutions are there. And second thing, right, after writing the paper, do resolve the paper on your own. Some of you, what you're doing, you're seeing the question, you didn't get in the exam, you think like that's a doubt. That is not a doubt. Exam, you didn't have enough time to solve it properly. You're supposed to resolve the paper again once more on your own. Spend time. If it's a 1 hour paper, you'll take at least 1.5 hours to resolve the paper. It is not a waste of time. Tell me one thing. Why didn't you get the question in the exam? Because you don't know something, right? Now, if you don't resolve the paper on your own and if you try to figure it out, what does it mean? You're losing an opportunity to learn. You can ask me, I'll tell you the answer. But then again, you did nothing. If the same question comes again after 1 month, again you do the mistake and come. Try it again. If you're still not getting, I'm always there. But the effort should come from your side first. I'm not going to give the JEE exam, no. Mera already ho gaya. You have to give. So do check it out. The next paper is a good one. So do take your time and write it properly. The next paper is actually 2006 ka paper 1 model. 2016 ka. It was one of the toughest model that time. Multiple choice was +4 and -2. I gave +4 -1 only. So that was the first time they said +4 -2. People got slaughtered that year. But that year the cutoffs also went down. 271 out of 360 was All India 19th rank. 75%. The next year they came back to normal. Next year 270 mein rank was 338. 2017 ka. Anyways, it was not 2016 ka paper, but model is that. You have 5 single choice questions, 6 multiple choice questions, and I think 2 paragraphs, I guess. How to do this thing? First thing, the kinetic energy. Paramita, who is this? Others, you need to keep your cams on, and please do change your names. I don't recognize this new person. Who is this? Okay. So how do we do this thing? Kinetic energy is Bs square. So kinetic energy is given by half mv square. This is Bs square. So we get V square is 2V by ms square. So A centripetal is given by V square by R. So 2B by mr s square. This is your centripetal acceleration. Differentiate on both sides. So this will be 2V dV by ds is 2B by m 2s. 2 will cancel. So V dV by ds is nothing but acceleration. 4V s by m. What acceleration is this? This is A tangential. So what is A net? Root over A centripetal square plus A tangential square. That is a mistake you guys are doing. You guys are not finding the tangential one, or maybe you're finding centripetal. You're finding one of them. So that would be 4b square s power 4 by m square r square plus 4b square s square by m square. That's your answer, everyone. Two people are absent. Who are these two? Neil, are you there? Neil is not there. Who is the other person? Ronak said he's not gone outside. So fair enough. Play with this, everyone. Neil, you're there. Then who is the guy who got missed out? Yeah, next one. We have a circular ring here. We have a spring connected to a, so there is a ring here. Ring of mass. And this is a smooth circular frame. Gravity is there. Huh? Spring constant is K. This was the center. This angle is 120 degrees. So this bead can slide. So this is a ring which can slide freely. Ring of mass and which can slide. So, and the radius of this thing is R. And the natural length of this guy, natural length of the spring is R. Initially, bead is moving with V. So at this instant, this bead ka speed is this way V. Find A centripetal, A tangential, normal reaction at this instant. Let's get this thing. I hope the question is clear. Anyone didn't get the question, please ask. This is the front P, okay? So gravity mg is also there on the ring. So this ring now, meaning if you are thinking how it will go, after some time it will become like this. The ring will be here and the ring will be here. So it is sliding. There, NLM and circular motion. Actually, circular motion, every question is NLM only. Next week or after that, we'll have a bonus test. It will be 60 questions in 1 hour. Questions will be slightly easy. And portion will be everything. Calculus, vectors, kinematics, laws of motion, friction, circular motion. In 1 hour. So the game is to see how many questions you can solve in 1 hour. Normally, I do this with your 12th standard students. When you become seniors, we do this, but I think we should start little early for you guys. It'll be fun. Meaning, I know, fun for me, not fun for you, but after some time it will be fun for you also. And if you're thinking, so people really solve that many questions. When I was in 12th, I can solve around 55 to 60 questions. My best was 72. My teacher used to give 100 questions. And last year, people were doing at least 55 to 40 questions. For 55 to 60 questions, people are doing also 1 hour when you're in 12th. But questions will be easy on. They'll not be like high level questions. Main se bhi thoda kam hai, maybe bits ka level. But 60 questions is fun. You get 1 minute to solve the question. You read, because I'm seeing now some of you are having this problem. You take a question, you're stuck with 5 minutes. You're not even realizing like, boss, मुझे एक question छोड़ के आगे जाना है. So in this paper, right, 60 questions, if you get stuck, so you're gone. 5 minutes, so 5 questions are gone. This was a pattern in 2005, 2006 AIEEE. I wrote it. We had 180 questions, 180 minutes. So next week, I'll let you know. This will be there in the class. Huh? Let's see, I'll give you a time slot and I will start the test. All of you will be there and we will do something like that. I'm arranging something for it. 1-2 weeks, we will have that test. We'll have it like that once in a while. For your seniors, the last year they wrote how many tests? 12 speed tests. We call it speed test. First 2 to 3 tests, they mess it up, but then the speed comes up. They do. Highest so far was one time I gave 90 minutes, 120 questions. Highest was 111, 107, right? That was Anuj. How to do this 26? Centripetal near Anika, you goofed up, I guess. Centripetal, why are you guys doing this? Centripetal is the most easiest one. Centripetal is what? V square by R. Bas ho gaya. What are you guys doing? Kya kar rahe ho? That spring force has nothing to do with centripetal there. V square by R. Bas ho gaya centripetal. Right, I'll give you a minute more. It's a good one. Show you. What is the elongation in the spring? That's the first part. What is the elongation in the spring? So this length, if you see now, this was R and R. This was R and this was R. Write it here. This was 60. This was 60. So this guy will be 2R sine 60. So that will be R root 3. So the elongation in the spring will be the final length minus initial length. So elongation X will be R root 3 minus R. There, that's your elongation, people. What are the forces acting on this guy? Spring force, Kx. This would be the normal reaction towards the center. Your own weight mg. That's it. Any other force? There are 3 forces. Since it is going in a circle, there will be a centripetal acceleration AC, which is v square by r. This will be a tangential acceleration AT. So if you resolve these forces, if this is 120, this will be 30. This is 60. So this is also 30. So I'll just draw the ring to FBD again. Normal reaction. Kx. This is that center line. This is mg. This was 30 and this was 30. This was A centripetal and this was A tangential. A centripetal तो आ गया, so A tangential will be Kx sine 30 minus mg sine 30 is equal to mass into A tangential. So just resolve the forces along the normal and perpendicular to normal. And this direction would be n. This would be Kx cos 30 plus mg cos 30. I'm resolving the forces along the normal. Minus normal reaction is mass into centripetal acceleration. From here you get n ka value. Please check. So this is along normal. If you want, I can resolve and show you. This would be mg sine 30. This would be kx sine 30. This would be kx cos 30. And this would be mg cos 30. Please check. Are the steps clear? So the spring force will act along the spring, but the normal will act towards the center. Mg will act down. There are only three forces. Since you're going in a circle, there'll be a centripetal acceleration and there's a tangential acceleration. So forces ka tangential components will give you A tangential. Along this thing will give you A centripetal. A centripetal is straightforward, V square by R. Clear with this? Clear? Next one. This is our top view. This is how it looks. So you have a curved road. The diagram would have looked like this. This is the side view. So we have a block here. This is theta. So basically this curve, basically it's like this theta, that curve part. So we have a block here which enters with speed u and leaves with speed v. So this is a rough wall. Friction is mu, the ground is smooth. I hope you're able to visualize how is this. So this block is entering like this. It enters u like this. So it is gliding on this wall and comes out with v. So this is a smooth ground, whereas this wall is rough. clear with this? How you're getting how is the diagram? So a block enters a curve and slides on the rough vertical wall. It enters with speed u and leaves with speed v. Find v. I hope the question is clear. Anyone not clear with the question, please ask. So there is a friction on the wall. You're getting it? So when it is gliding on the wall, there's a friction on the wall. Mg will act downward. So you need to understand who is providing the normal reaction. What is this friction doing? Think about it for a minute, then I'll show you. See, listen to this question, son. These kind of questions, right? Not exactly question, but these kind of mathematical functions, you will encounter a lot. Listen to the story, how I put it. As the block enters, there will be a centrifugal force, which is pushing this way, which is mv square by r. This will give the normal reaction. And because of that, you get a friction. Fair enough? So this friction will be mu into mv square by r. Now look at the story, what happens. Because of the friction, speed will decrease. See, friction is mu mv square by r. Because of friction, speed will decrease. If speed decreases, friction will decrease. If friction decreases, then the acceleration will decrease. So speed won't decrease as fast as before. Are you getting that word? If speed is decreasing, friction will decrease. If the friction decreases, then acceleration is less. Deceleration. So since the deceleration is less, your speed is decreasing, but not as fast as before. So speed v will decrease again. Again, friction will decrease. You're getting what is happening? This function is killing itself. This function, right? It is killing itself. The more you have velocity, more friction you have, the more you will decelerate, and so on. These kind of functions, right? Mathematically, we call them decay functions because the value keeps on decaying. Are you getting this? So these kind of functions, now, generally 99% of the time, these kind of functions, the answer will come in terms of e power something. Keep this in mind. It will be quite useful when you have to guess the options. So the option should look something like e to the power of minus something. It's a decay function, exponentially decay functions. Let's see how to solve. And this is not the first time. You'll encounter this kind of story multiple times, maybe at least 9-10 times. You will see in a lot of chapters. The function is killing itself. Technical word is the function is decaying. So let's see how to do. How we draw this thing. So if you take the block here, so this is your mg. This is your normal reaction due to the ground. This would be your normal reaction due to the wall. This will be your centrifugal force. This would be the friction. Is the diagram clear? And this friction is due to what? This is friction due to wall. Ground में friction नहीं है, it is smooth. And we have a tangential acceleration backward. So we have normal reaction due to wall is mass into centrifugal force. Now tell me one thing, if I use centrifugal force, where is the observer? Anyone? Where is the observer?
On the block now.
On the block. So I kept the observer on the block. In the previous question, I took the ring, na? I took centripetal acceleration. Where is the observer? On the ground. You're getting it? So which one to use? You can use whichever you want. There is no problem there. But इतना clarity होना चाहिए that if I use centrifugal force, don't talk about centripetal acceleration. If I use the word centripetal acceleration, don't talk about centrifugal force. Is that fine? So if you see na, sometimes in question, right, I use centripetal acceleration, sometimes use centrifugal force. I keep on mixing it up. So if that is confusing you, you decide which one to use, centrifugal or centripetal. So it is mainly about the observer. So there is nothing wrong. You can use either of them. I keep using both of them, because so that you guys get used to that. So whenever you ask yourself, why am I using centrifugal force? Just say observer is on the body. So friction on the wall will be mu into n wall. It is sliding, so it is maximum. This is mu mv square by r. So this will be mass into acceleration, A tangential. Mm will cancel. This guy will be minus v dv by ds. This is mu v square by r. Minus because it is decelerating. If A and V are in the opposite direction, you always get a minus sign. Minus dv by dt minus v dv by ds. One v will cancel. You end up with minus dv by v is equal to mu ds by r. Integrate on both sides. dv by v is equal to minus mu by r integral ds. Initial speed is u, final speed is v, distance is 0 and r theta. You're covering a distance of r into theta. The total distance traveled. This guy would be ln v minus ln u. This will be minus mu r theta by r. This will become v by u is equal to e to the power of minus mu theta. I removed that log term, okay? U into e power minus mu theta. There, that's your velocity as function of theta. This is what I was saying. Whenever you have functions like this, they're decay functions. Options will be in the terms of e power something. It will never stop. Because the slower you're going, the lesser the normal reaction, lesser the friction. The function is killing itself. Check this out. Any doubts on this? Anyone not convinced with any particular step, please ask. Clear? Next one. Next one is a good one. We have a rod here, cylindrical rod. You have a ring. ring of mass, and it just fits over the cylindrical rod. And this started rotating with alpha. Alpha is the angular acceleration. So kind of this is the first time you're bringing alpha actually into problems. The rod has a friction mu, gravity is also there, and this radius is r. So initial angular velocity is 0. Find time when the thing starts slipping. Just to explain you the question, did you ever do this in school? You have the fan, you keep the duster on top of the fan. Ever did this? And then you switch on the fan. So for some time, the duster will go with the fan and then it flies off. Able to visualize? It is the same story there. So you have a ring here. Once you switch on the fan, this thing will start going in circle, circle, circle. At one point, it will be friction, the centrifugal force will be so high, the ring will start moving outside. I hope you're getting the scenario how it is. It is exactly like putting a duster or a coin on top of your fan and then switching on the fan. As the fan starts going faster and faster, the coin will slip. So the question is, after what time will this ring slip? Same question. But this B part, this will be like a paragraph. If you replace this ring with a square frame, everything is same. If this was a paragraph question, I'll ask you these two questions. If his ring is replaced by a square frame, how will the answer change? Now find the time taken. Let's get these two. First get the ring, then we can do the square. How will the shape matter? That's what we need to see. Remember, this rod is cylindrical. Meaning it's like the cylindrical cross section. Anyone confused with the question, please ask. Root mu g by r divided by alpha. Name Aditya. You're missing something. Gravity hai, huh? Mg is there. Don't forget that. Anyone confused with the question, please ask. So, first of all, you should be clear with the scenario. Huh? Again, I'm telling you, question should be always clear. If you're not understanding the question, it is my fault. If you're not understanding how to do, that is okay. I'll teach you anyways, but you figure it out, put a fight. So it is important to understand the question. So never hesitate if you didn't understand what it is, just ask again, get it cleared. But the best way to visualize this is that only put a duster on top of the fan and switch it on. That is the reason. If school, if you're a very good and sincere student, physics will be a little difficult. You have to do if you did a lot of nonsense things like this, it is very fast to visualize. I never used to do such things. I used to take a chalk piece powder, make it into fine powder, and put it on the top of the fan. That used to be more fun. When you switch on the fan, the entire classroom will be full of dust or powder. That used to be more messy. Actually, one time someone did that. The teacher came and switched on the fan. The duster went and hit the teacher only. It became a big mess that day. So the social teacher. Root mu g r by alpha. No, that is not the answer. It's forgetting something. how will this ring look like in the first place? Let me show you something. Suppose if the ring was at rest, if there is no rotation, can you tell me how will the ring be? This is that cylinder. The ring will look like this. Agreed? It will be touching on the top, no? Are you getting it? It is like, if you can see my screen, right? If there's a ring, if I just put something here, the entire weight will be like this, isn't it? It will be touching the top part. Suppose if you're just accelerating horizontally, then how it will touch? It will drag like this, no? So where will the ring touch? Ring will touch horizontally, isn't it? So if there is no gravity and only rotation, but only rotation, the ring will actually touch like this. You're getting it? Now, if you have both of them, the actually ring will touch like this. Are you getting? It will be touching at an angle. That ring and that rod, right? They will be touching at an angle. So we will have a normal reaction like this, which will have two components, an Ny and Nx. So basically this will provide that Nx. And this will provide that Ny. Are you getting how the diagram looks from the side view? The contact will be at an angle. It will not touch on the top. It will not touch horizontally. It will touch it somewhere in the middle. So there is only one normal reaction. If there's one point of contact, there's one normal reaction, but that will be at an angle. Anyone not clear with this diagram, please ask me. So if you put a ring over a rod, this is how that rod will look. The ring will be touching the rod at an angle. If there is no rotation, it will touch on the topmost point. If there is no gravity, it will touch horizontally. If you have both of them, it will touch at an angle. So this has both gravity and rotation. Now, if you draw the FBD diagram, look at the forces here, okay? You have Ny, you have Nx. Understand this Nx will be tangential. You have your own weight mg, you have friction force, and you have centrifugal force m omega square r. What is this Nx doing? This will be your tangential acceleration at, which is r alpha. So Ny is balancing your weight mg. Nx is providing the tangential acceleration m into at. Are you getting this? So the two components are playing two roles. The normal reaction in the y direction is balancing the weight, and the horizontal one is providing the tangential acceleration. The ring is not at rest, it is accelerating. So Ny is mg, and this guy will be mr alpha. So the normal reaction will be root over Ny square plus Nx square. This is the catch, everyone. The normal reaction won't have only one component, it'll have two components there. This will be root over m into g square plus r square alpha square. And friction will be mu into n. This is the maximum friction. This will be mu into m into root over g square plus r square alpha square. This should be equal to how much? Centrifugal force. F max should be equal to m omega square r. And what is omega? Omega final is omega initial plus alpha t, kinematics. So omega final will be alpha t. So this guy will be mu into n. This is mu into m into root over g square plus r square alpha square is m into this guy will be alpha square t square into r. M will cancel, shift everything that side. You end up with t is equal to mu by r alpha square root over g square plus r square alpha square ka whole power r. There, that is the time when it slips. So the most common mistake is people either take only nx, people take only ny. You need to remember you have both of them. And since there's only one point of contact, you get only one normal reaction. Since there is only one point of contact, we get one normal reaction. And that one normal reaction ka two components are doing all the work. So the net normal reaction will be nx square plus ny square. Please check the steps. This will be a good paragraph question for advanced math. If you say it's really not difficult to solve, if you understand. Understanding is the main thing what is happening. So as you go faster and faster, the centrifugal force is dragging the ring out. Since omega is increasing, eventually it will exceed the friction ka maximum value and you'll go out. Again, I'm using centrifugal force. The observer is on the ring. Please check it out. So normal reaction got two components, friction along the rod, centrifugal force and mg. Anyone not clear with the steps, please ask. Now, can you do for the square frame? So what changes for the square? So using this as a reference, can you do what will change for the square frame? So if you keep a square frame here, how will the answer change? Try, I'll give you a minute or two. Mass is same. The square frame just fits the ring. Radius are, everything is same, mu, everything. Think. I'll give you a minute or two. How does your answer change instead of a ring if you use a square frame? And right answer, right Aryan, Arjun, Aryan, right. Idea is right. Solve. I think you got the right idea there. Try. Others, everyone should try. Niranjan, all clear so far? This is clear. Ritu, clear now with this thing? Ritu, clear? Sure? Neil? Clear, Neil? Aditya? Arjun? Clear?
Yes, sir.
Vastika? Yasha? Clear with this? Rehan?
Yes, sir.
Vartika? Clear? Everyone do adjust your cams a bit. Make sure I can see your face completely. All I can see is your beautiful hairstyles, but that is good. Still, please show your faces. How does your answer change if I use a square frame? Try. Root mu alpha. How are you getting the mu alpha? It's not the answer. See, what is the difference between the square frame and this? If you look at the rod now, that square frame will be like this now. It will have 2 points of contact. Isn't it? If you put a square frame over a circle, it will touch at 2 points. So this would be ny, this would be nx. So equation, everything will look same. The only difference is now there will be 2 frictions. That's the difference. If there are 2 points of contact, there will be 2 frictions. So if you try to draw the FBD there, you have ny, you have nx, you have fy, and you have fx, mg, and centrifugal force. So we get fx plus fy will be m omega square r. So this guy would be mu nx plus ny. That is the difference. Observe this thing here. N was what? Mu n x square plus ny square. But here it is nx plus ny. Which is bigger, a plus b or root over a square plus b square? A plus b or root over a square plus b square. This is greater now. A plus b is greater than root over a square plus b square. So that means the square frame will have more friction compared to the ring. So a simple question would be, which will slip first? The ring will slip first. This would be m, omega will be alpha t whole square by r. So this guy would be mu mg ma tangential, that is mr alpha plus mg is m alpha square t square r. M cancels off. You get mu r alpha plus g by alpha square r to the power of half this time. Please check. You guys are forgetting mg. I forgot one other friction. Remember, there'll be 2 frictions, fx and fy. That is the difference. In the previous case, there's only one normal reaction, so you get only one friction. And that n is root over nx square plus ny square. But here there are 2 normal reactions, 2 point of contact to 2 frictions. So that will make the difference in frictions. You're getting it? So just by changing the shape, the whole question will change. This is how they'll frame questions in advance. Did you observe? Bada concept nahi tha. But just realizing that when you put a ring, a square frame over a circle, you get 2 points of contact. You can make the question even more deadly by putting a triangle. But let's not do that. In this case, you'll get normal reactions, nx, ny at an angles. That will be more fun. It is just mathematically more tough to calculate, but it is possible to do. So nx, ny horizontal components will provide ma tangential, the vertical components will provide mg. Here also you'll get 2 frictions. Any doubts on this? Please ask me. The difference between a ring and a square frame.
So for shapes with more sides, it would be the same as the square only, right? Like the pen.
That's only 2 points now.
Uh,
You can't touch more than 2 points. If you take even a hexagon, what will happen? It will touch this corner only.
yeah.
It won't matter. But so angles में difference आएगा, but it's only 2 point of contact. Clear with the ring and square, everyone? Dhrit? Clear? Aryan, Neil? Clear? Palaksh, Vidyut? Clear, na? Niranjan, Udyan? If rod is a square shaped, और कौन सा shape चाहिए मौलिका? Ring is what shape? Rod is square. Ring कौन सा shape चाहिए? Ring is also 1 to square. Then so it is only 2 points of contact. So then this time it will be more surface contact basically. It will be like this, isn't it? It's exactly it in that corner. So you will do that same only n by nx. So कुछ difference नहीं है, actual answer will remain same. But if you take a square rod and a circle ring, then you can get actually multiple things. So you can get three contacts at least. It'll become more complex actually. Clear? Someone wants to put a benzene ring. अब इतना rings मत डाल के चलो तो. Next one. Someone is so much into chemistry. Next one. So those are some of the questions on non-uniform circular motion. The next one is radius of curvature. What is this radius of curvature? So whenever you have any curved path, a segment of a curve can be treated as a part of a circle. The radius of this circle is called radius of curvature. That means in reality, right, whatever constructions that you see in real world, even though you see some random curve, especially if you gone to Imagica, you must have seen that rides, the Nitro car ride. If you see the whole thing, right, it looks totally random. But in reality, every section is a circle. Radius of the circle is called radius of curvature. Let me show you how it looks. So if you give me some random shape like this, so at this point, if you take this small segment, I can assume this is a part of this circle. I can assume this is a part of this circle. I can assume this curve is part of this circle. I can assume this is part of this circle. So basically, you can treat every small section as a part of a circle. So where this thing, let's say, is R1, R2, R3, R4. So tomorrow, if you're an architect, right, and you are trying to construct some kind of curvy shape, when you give the engineering people a design, you can't say draw me a parabola. They won't understand. You have to give them, from here to here, this section, the radius of curvature is 10 meters. Then the second section, the radius of curvature is 11 meters. So what they'll construct is circles only. You have to assemble them. When you assemble the entire thing, it looks like some random curve. Whereas in reality, every section is a part of some circle of different radius. So when you go to this Imagica and see that Nitro ride, which looks like this, in reality, every section here is a circle. This thing is another circle. This is another circle. So what they join is different arcs, and each arc has a different radius of curvature. So basically, a curved path can be treated as an assembly small arcs or small lines. And this comes because of the integration thing. You would have taken the elements so small, you can assume they're arcs or you can assume they're like lines. So if you give me some random curve like this, if I take ds, very small part, you can say it's an arc length, or you can also say it's a straight line. It works both way. ds can be treated like an arc or a line, just because it is very small. Have a look at this. This is the meaning of radius of curvature. So every random curve, any curve that you take, you can always treat it as a combination of lots of small circular segments. Circular segments ka radius will be different, but it works. Have a look at this. Clear? Next one. Any doubts on this? So how do you find this radius of curvature? There are two ways you can do this. One is physics and one is more mathematical. Let's see the first part. So if a body has velocity v, and let's say this is your acceleration you can take in any way. So you can divide the acceleration into two parts, a cos theta, which is a perpendicular, and a sin theta. This will be your a tangential. So acceleration parallel to v is tangential, and this guy is your centripetal. And we know a centripetal is v square by r. So radius of curvature is v square by a centripetal. That's how we can find the radius of curvature. So anytime you have any random curve, so let's say this guy is going with velocity v, you can divide the acceleration into two parts, a centripetal, a tangential. So this is how you would resolve the acceleration along velocity and perpendicular to velocity. The perpendicular component will behave like centripetal, and radius of curvature is v square by a perpendicular. So this is completely physics method. Let me show you an example how it works. But please check this out. Example, let me show you a question. A particle is projected with u and theta. So as it is flying here, at this point, let the velocity be v and alpha. Okay, so now I can ask you find the radius of curvature. Now you need to understand this parabola which you're having, you can treat this thing like circle, circle, circle. So you can treat that entire parabola is made of again small circles. Meaning here the small parts. This each segment can be treated as a part of a circle. So during this velocity at any instant alpha, understand gravity is always acting down. Acceleration is constant. So if you resolve this into components alpha, we get this thing as g cos alpha, and this is g sin alpha. So a centripetal is g cos alpha. They can ask you this question also. Find the tangential acceleration of a particle in a projectile motion. A tangential is g sin alpha. So radius of curvature will be v square by a centripetal, which is v square by g cos alpha. And we also know during the projectile motion, u cos theta is equal to v cos alpha. So this will become u square cos square theta by g cos cube alpha. This is the radius of curvature as function of alpha. This is how they'll frame a question. At the highest point, velocity will be u cos theta, and the gravity will be g downward perpendicular. So at the highest point, you get the minimum radius of curvature. At h max, the minimum radius of curvature, basically alpha is 0. Will be u square cos square theta by g. That is your minimum. Have a look at this. And I hope you remember how to find alpha. Tan alpha is u sine theta minus gt by u cos theta. In case you forgot kinematics projectile motion, it is back. Check it out. This is how the last questions. Find the radius of curvature when the angle becomes alpha. Find the tangential acceleration after time t. Find the centripetal acceleration after time t. So you can ask questions even for a projectile motion. A particle in projectile motion can be treated as non-uniform circular motion. Please check. This is how they'll frame questions. Any doubts on this? Abhinav, clear with this?
Yes.
Yasha, Venkatesh? Everyone clear with this example? Please check this out. So even you can ask in a projectile motion, find tangential and centripetal acceleration. So this tangential and centripetal, understand it is not always for circular motion. Even though we studied non-uniform circular motion, you can actually apply this for motions other than circle also. So this is a case which we are studying now. These are not going in circles. So this is like a circular motion with variable radius. Actually, you shouldn't call it circle anymore. All clear with this? Let's see a question on this. So we have a parabola here, y is equal to x square. We have a small bead here, which can slide over the parabolic bead, can slide on the parabol. Bead of mass m. Slides on the parabola such that the horizontal velocity, not the total velocity, horizontal velocity of the bead is constant. Meaning this guy is going with u. So when the bead comes here, the velocity is some direction v, but the horizontal component is u. You're getting it? Let the bead go with any velocity. Let this be v2. But the horizontal velocity is u. I hope you're getting what is happening. Speed is, the bead is not constant. वो change हो रहा है, but horizontal velocity is constant. Find a centripetal, a tangential, and radius of curvature at 1, 1. Let's get this. That means there are some external forces on the system which are making this happen. It can't go on its own. You can't have a constant velocity on its own. So someone is driving it. We don't know who is that. What are the forces? कुछ idea नहीं है. Only information you have is the horizontal velocity is constant u. And the equation of the parabola is y is equal to x square. I hope the diagram is clear. The ring is sliding on the parabola such that horizontal velocity is constant. Vertical is changing. find the centripetal, tangential, and the radius of curvature at 1, 1. These are the kind of questions you'll get in, paragraph or matrix matching questions. Mostly this would be a paragraph or a matrix matching. Try. It's a good one. Let's see how will you figure this out. Again, I'll tell you one thing. What is tangential? What is centripetal exactly? Acceleration component parallel to velocity is called tangential. Acceleration component perpendicular to velocity is called centripetal. Bas itna hi hai. Are you getting it? So don't think too much about like, oh, what is tangential? Tangential, parallel to velocity. Centripetal, perpendicular to velocity. Get this. Anyone not clear with the question, please ask. Just give it a try. I'll get some water and come. At 0. 80. Nere. 5 √5 u square by g. What is that? Radius of curvature. Aditya. Let's see. I'll tell you one thing. See. Whenever you get a question, right, forget about solving the question. That's the first thing you need to do. Forget about the damn question. Start thinking, what data do I have? What data do you have? The biggest clue is this guy. The horizontal velocity is constant. उसके साथ क्या कर सकते हैं वो सोचो. Centripetal, tangential बाद में देखते हैं. What does this information is giving you? Instead of trying to find what you don't know, always try to see what you have. This is how you can be happy in life. Instead of thinking, I don't have this, I don't have that, be grateful for what you have. That will make you more peaceful. What does this give you? Since the horizontal velocity is constant, it will give you x coordinate. X is equal to u into t. Agreed? Fair enough. If x coordinate you know, then you know y coordinate also. Y is equal to x square. So y will be u square t square. Again, what is velocity? So vx will be dx by dt, which is u, that I already know anyways. Acceleration is 0 because it is constant. Vy will be 2u square t, and ay is 2u square. Therefore, the speed at any instant will be root over vx square plus vy square. So that comes out to be root over u square plus vy square. I can write this thing as 2ut. Can I leave it in u only? So that will be 4u power 4t square. I'll write it as vy only. I'll keep it like vy only. There I got the speed also. There I got the speed, I got the acceleration. Now look at this motion, how it looks. So at 1,1, the acceleration is in this direction. There's only ay. Velocity in this direction v. And I can find this angle theta, which is tan theta is dy by dx. Which is how much? Y is equal to x square. That would be 2x. So at x is equal to 1, I get tan theta is equal to 2. So if this angle is theta, this angle would be 90 minus theta. So this angle also will be 90 minus theta. So if you resolve the components here, this will be a. So this is your velocity. This is 90 minus theta. So this is a cos 90 minus theta. So a sin theta. So this is your a tangential. This is a cos theta. That is your a centripetal. You got everything here. So take a triangle 2, 1. This is theta. This is root 5. The a tangential is a sin theta. That is 2a root by 5. What is a ka value? 2u square. 4u square by root 5. What is a centripetal? A cos theta. So cos theta will be 1 by root 5. What is a? 2u square. 2u square by root 5. What is radius of curvature? Speed v square by a centripetal. What is v? Root over u square plus vy square. And a centripetal ka value, to you know. Dump everything, then we get the answers. And it is given x is equal to ut and x is equal to 1. So time bhi aa jayega yahan se 1 by u. You know everything. You can put there and you can get the answers. So I can actually calculate this, I guess. That x is equal to 1. T is 1 by u. Speed will be root over u square plus vy square will be 1 by u. 2u ka whole square. So that will be root 5u. This is the speed at 1,1. So I can actually dump this thing here. So root 5u by a centripetal is 2u square by root 5. 5 by 2u. That's your answer. Check this, everyone. I know the dimensions don't look right. That is because y is equal to x square. Here there is a constant has some dimensions which are ignoring. Again, I'll explain the whole thing. Listen carefully what I did. The first thing is horizontal velocity is constant. So I took x is equal to ut. If I know x coordinate, I know y coordinate. So if I differentiate x coordinate, I get velocity. If I differentiate, I get acceleration. Horizontal mein acceleration hai hi nahi, it is 0. If I differentiate y coordinate, I got vy. If I differentiate, I got ay. That means there's only one acceleration in the vertical direction. So the net acceleration is upward. The velocity is tangential. The acceleration is upward. Velocity is tangential. Since it is tangential, I can find the angle tan theta. Acceleration is upward. So divide the acceleration along velocity and perpendicular to velocity. Along the velocity is tangential, perpendicular is centripetal. Please check the steps. So the whole question starts from that statement that x is equal to ut. Agar wo figure out nahi kiya, if you don't get this thing, then you're stuck. I goofed up this thing. This is v square now. So that would be 5u square by 2u square by root 5. 5 by 2. Check. I hope the process is clear, everyone. Again, I'm telling you, class gets over today, tomorrow maximum, you have to take out the notes, take a rough paper and resolve all this on your own. If you don't do this, you're just wasting your time coming to the class. Let me put it very clear. You are losing an opportunity. Your chances of getting into IIT or BITS will decrease drastically. Because this is not a one-time thing. हर class के बाद करना है ये. Because every time you ignore solving it, you will forget most of it. After 1 week, all this will look like nonsense. Greek and Latin जैसे लगेगा ये सब. And just to cover up this portion, you will spend another 1.5 to 2 hours. This is something which you could have revised in half an hour. You're spending 2 hours later on. You're wasting time. And then later on, you'll cry, sir, I'm not getting enough time to study. I'm having a backlog. That is because you are not resolving the notes or resolving the papers again. Again, I'm telling you, getting into IIT or any exam, any entrance exam, right? It is not about learning a lot of new things. Whatever you learned, you have to repeatedly solve them again. Revision, एक revision, second revision, third revision. We are doing already different varieties. काफी है इतना different models. But these models only you don't understand. If these questions come in the exam, you won't solve. You will leave the paper and come. What is the use? Tell me one thing. If these same questions come in the exam after 2 weeks, trust me, half of you won't be able to do. You know what you will say? Arre sir, na ye exam mein kiya tha, class mein kiya tha, but I don't know what to do. You ever get this feeling? You see the question in the exam and you feel like, arre, I have seen this question in the book, but I don't know what to do. I have seen this in the notes. I don't know what to do. I have seen this in the textbook. I don't know what to do. Meaning, kya fayda? What is the use of saying I have seen this, but I don't know what to do? Are you getting this point? Again, see, advancement, no one is asking you to score 100. हमको कितना score करना है? If you score 50 to 60 marks out of 100 in advance, you'll get a pretty good rank. ठीक है ना? मतलब that 10-20% will be super unique questions. Let them go to hell, na? Do the remaining 70% properly and come. Why are you running behind the 10-20% of super questions and you're messing up the regular ones? Resolve the notes. If you're not taking these words seriously, every class I tell you this is like a broken tape recorder. Understand why I'm saying this? This is the reason why most people, struggle. They think, "Arey, JEE बहुत tough है." JEE tough नहीं है. You are not sincere enough to do the work. You're not disciplined to do the work on regular basis. That's why the exam becomes tough. School में आदत नहीं है ना. We used to study 1 week before maybe, and still got 95%. So the brain remembers that. All clear with this question? Any doubts, please ask. I'm telling you again, what will get you into IIT or what will get you to have a good life later on is your daily habits. Not your IQ. Trust me, it is not your IQ. I have seen brilliant students not doing anything in life. I have seen average students, but with a proper discipline, working on regular basis, you will do a lot. Yeah, next one. Let's do an easy one. We have a random curve like this. Gravity is there. We have a vehicle of mass m going with speed u. This is point A, this is point B, this is point C, and this is point D. So a vehicle of mass m goes on a curved track with constant speed u. Speed is constant. Arrange the normal reactions at A, B, C, D in ascending order. So A, B, C, D, whatever normal reactions you get, arrange them in ascending or descending order. Doesn't matter. Let's get this. So this vehicle is going on some random curve, gravity is there. So at every point you get a different normal reaction. I'll do one thing, wait. Diagram is fine, but it might give you some confusion. This is better. Basically C and D are sharp. A and B are little broad. This will be a proper good means level question. CADB. Okay. So if you look at the FBD here, Na, Mg, the centrifugal force is mu square by Ra. Nb, Mg, the centrifugal force will be away from the center, understand? So here it is like this. This is the circle. This is the circle. So it will be away from the center. This is the circle and this is the circle. So C and D are small circles. Nc, Mg, mu square by Rc. Nd, Mg, mu square by Rd. So if you look at the normal reactions here, we get Na will be Mg minus mu square by Ra. So the normal is definitely less than Mg. So Nb will be Mg plus mu square by Rb. So if you see the normal increase, this is what actually happens in a roller coaster ride. So when you're on a roller coaster ride and you're going like this, what happens is at this point now your weight is less. You feel the gravity is less. Suddenly you feel gravity is more. Again, suddenly you feel your gravity is less. Your body ka weight is changing continuously. So your body is under a lot of stress. Your brain goes mad like, yaar, kya ho raha hai body ke saath? So it starts releasing adrenaline. You know, this flight of leave, we call it. The body is actually generating all these kind of hormones, right, for you to survive. You think it is excitement. The brain thinks, shit, I'm dying. Getting it? So that is the difference basically. Now, you're getting it. So you are like, oh, you feel excitement because of the hormonal rush. The brain is doing all that thing so that you will survive and you don't die. So it's a miscommunication between brain and heart. But yeah, so you get confused. You think you're having fun, but some people right get scared. That is because of that. The threshold exceeds their fun ka limit. So if you see some people, they just sit there as if nothing happened. Like, kya hai ye? Yeah. If you have gone to I have been to Singapore mein, there's Universal Studios. So if you have gone to something of that kind of dangerous thing, right? Meaning the ride is like this. You sit there like this. There's nothing below. You're just hanging there. First it goes straight, right? Then you go up and down. Then this thing starts rotating. Getting it? And then you come down and there's a water there. You flush through the water and you come out. So it is like pretty deadly kind of thing. When it rotates, so you go mad, like what is happening? So when you have done something like that, so I went 13 times in that. I was getting down, I was running and going in. I was getting down, I was going and running in inside. It was fun. So when you do something like that and you come to, our this Imagica thing, that is like this. It's like, oh, okay, fine, kind of like ठीक है, not a big deal. So basically, and one more thing, if you ever notice, right, next time if you go by any chance, you notice this thing. When people are going now, it will be like this thing. See, the sound goes off for a moment. If you ever observe, the moment they reach the bottommost point, the sound goes off. When they're coming here, it'll be like again the sound comes. The sound goes off in this region. You know why? You're going at such a high speed. If you look at your weight at NB, let's say if U is equal to some 3 rg or something, the gravity will be 4 times. So at that lowest point, your body will experience your gravity has become almost 3 to 4 times. Because of that, the air from your lungs is expelled outside momentarily. And if there is no air in your lungs, what will happen? There will be no sound. So everything becomes quiet. And then once you come up again, you breathe and you make the sound comes out. You're getting it? Not because everyone decided, yeah, when we go down, don't shout, let's be quiet. Aisa nahi hai. So that is the thing. Next time, observe this. When you go to these rides, now you will see this thing. They all are shouting. Suddenly, everyone becomes quiet for a moment, and again, sound comes. These are the problems with physics teachers. Instead of going and enjoying the ride, you study all this stuff. So NC will be again what? Mg minus mu square by Rc. ND will be Mg plus mu square by Rd. So if you observe here, definitely A and C are smaller, B and D are greater. Between A and C, who is bigger? Radius of curvature Ra is greater than Rc. Therefore, mu square by Ra is less than mu square by Rc. So the negative value is smaller. Therefore, Na is greater than Nc. Getting this? Similarly, between B and D, D is smaller. Therefore, that radius is bigger. So out of all, the biggest guy is Nd. Then comes Nb. Then comes Na. And then becomes Nc. I ask you ascending order to CABD. I wrote descending order. Check this out. Yeah, CABD is the answer. DBAC is the descending one. Okay, anything is fine. Please check this thing. Yeah, any doubts on this? We assume NB is greater. Why are we assuming? We have proved it, right? देखो ना ये माइनस था ये प्लस था डेफिनेटली NB is greater than Na. Why do we need to assume? ठीक है? All got this? Next thing, there's another way to find radius of curvature. The mathematical value for radius of curvature. This will be slightly out of portion. If at all they ask you something like this, they have to explain this in a paragraph and ask you. So let's say we have some random curve. So you're trying to find this radius here R. Let this be an angle d theta. I'm exaggerating d theta. इतना बड़ा नहीं होगा, but it should be very small. So this is your ds. So if you look at this ds part here, this can be treated as dy, dx, and d theta. So we can write ds will be root over dx whole square plus dy whole square. Take out dx common, so ds can be written as r into d theta If you take out dx common, you end up with 1 plus dy by dx ka whole square to the power of half. And from here we also know tan theta is equal to dy by dx. Differentiate on both sides. This will be secant square theta d theta by dx will be d square y by dx square, double differential. So from here we can write r is equal to dx by d theta. I'll do one thing, I'll simplify this only here. So dx by d theta is secant square theta is 1 plus tan square theta by d square y by dx square. Tan square theta is nothing but 1 plus dy by dx whole square by d square y by dx square. Take this and substitute here. We get r is equal to dx by d theta. Again, the derivation is not really that important. 1 plus dy by dx whole square to the power of 3 by 2 . So basically I need to substitute here. I'll write on the next page. The final answer will be 1 plus dy by dx whole square to the power of 3 by 2 by d square y by dx square. This is your radius of curvature ka formula. So once you got this dx by theta, take it and put it here. Just have a look at this, what we did. Derivation is really not that important. Like I said, it's kind of out of portion. Look at the final formula here. Example. If you take this parabola, y is equal to x square, and if you try to find 1, 1, so we are trying to find the radius of curvature at this point. This is the problem we did, remember? So look at this formula now. So dy by dx will be 2x. D square y by dx square is 2. Substitute in the formula. The radius of curvature will be 1 plus 2x whole square to the power of 3 by 2 by 2. Here x is equal to 1. If I substitute that, that will be 1 plus 2, 5 to the power of 3 by 2 by 2. This is 5 root 5 by 2. What did we get here? I think we goofed up here only. I was getting a feeling we goofed up. Or did I goof up here?
होगा ना वो.
Where? Here?
root 5.
So you didn't take the root 5.
यहाँ पे 5 root 5 नहीं लिया मैंने. There. Did you see? Same answer. But you got it quite fast if you know this thing. So this will give you the answers fast. But if you ask you a tangential centripetal, कुछ भी नहीं आएगा इसमें से. This will just give you radius of curvature. So this is useful that way. Have a look at this. So this is the radius of that point. Any doubts on this? Please ask. So this will give you radius of curvature results without putting a lot of effort.
Sir, could you show the last page once? Yeah, thank you, sir.
Let's see how can they frame a good question on this. Any doubts on this? Anyone not clear with this, not convinced with this? Please ask. Differentiate with respect to x. Clear? Let's see a question. Last one for the day. With this will be done with the chapter. Next class we'll start with the work power energy. We have a curve here, y is equal to x cubed by 3. Friction, mu is equal to half. We have a block of mass here, 10 kg, going with a constant speed of 10 meter per second. So we have a point here, 1, 1. Gravity is there. A 10 kg block slides on a curved path, rough curved path. With constant speed 10 meter per second. Find the frictional force at 1, 1. Find normal reaction and friction at 1, 1. Let's get this. Previous page there. You can put down that formula in case you have not written it down. You are going to need this. 1 plus dy by dx whole square to the power of 3 by 2 by double definition. Yeah. Let's get this. So you have a curve y is equal to x cubed by 3, which is rough, mu is equal to half. This block is sliding with a constant speed. Once the friction is maximum. Find the normal reaction and the friction at 1, 1. How do we do this? Let's try and give you another 2 minutes. If you see, we did some pretty good ones today. The parabola thing, this one, that ring and that square frame, that velocity changing with theta. There are a lot of good questions today. You should definitely try this on all on your own again. You can do it today only at 10 o'clock. After your dinner is over, take a rough paper and try them on your own. Or tomorrow is also fine. But maximum 1 day. Again, it is not because of I wanted to do it for 1 day. This is a study by a European university. What these people realize, whatever you study, right, within 1 day, it almost decays to 70-80%. If you don't revise within 12-14 hours, it decays to almost 70-80%. It decays. Within a week, it is almost zero. You start feeling like everything is new. So what they suggested is if you can revise this within a day, you can bring it back to zero. If you can revise within, and again, it starts decaying, but this time slower. Then if you can revise this after a week, again, it comes there. Then you can revise it only once in 3 months or 6 months. It will almost be maintained. So 3 revisions, 1 day, 1 week, 2 months or 1 month. Then it stays with you for longer. How to do this thing? Let's see. Curve. So at 1, 1, first thing is this incline. This is theta. Tan theta dy by dx, x cubed by 3, na? That would be x square. That x is equal to 1, so theta is 45. I gave you a good number. So if you look at the FBD of this, the block, This is mg. So the components will be mg cos theta, mg sin theta, normal reaction, and friction. These are all the forces. Now, the most common mistake what people do, they write n is mg cos theta, which is not true. Here n will be n minus mg cos theta. It is going in a circle, so there is a centripetal acceleration. If I use centripetal acceleration, where is the observer? On the ground. This is v square by r. So the normal reaction will be mg cos theta plus mv square by r. So there, this is where you needed r ka value. How will you get that r? From that mathematical thing. So radius of curvature r will be 1 plus dy by dx whole square 3 by 2 square 3 by 2 by double differential. So when you do this, you end up with 1 plus dy by dx whole square is x square ka whole square ka 3 by 2 by double differential is 2x. Put x is equal to 1. So radius would be 2 to the power of 3 by 2 by 2, which is root 2. There you got r ka value, m ka value, theta ka value. Friction is what? Since it is slipping, it is maximum u into n. That's your answer. So the main catch is n is not mg cos theta. Mg cos theta plus mv square by r, but that r will come from radius of curvature. Once you got n, friction is mu into n. So there are some external forces which are dragging this block. So how much is this value turning out to be? Mu is half mg, m is 10, 100 cos 45 plus 10, velocity is 10 square, so 100 by root 2. वो होगा 1100 by 2 root 2, that is 550 by root 2. Am I right? Anyone got this? Mg sin theta is useless here. Mg cos theta, m is 10, g is 10, so 100 cos 45 is 1 by root 2. M is 10 and velocity is 10, so that is 100. So 1000, 1100 looks right. Check your calculations, everyone. No, did I go up somewhere? Please check. I hope the steps are clear. So if you don't know the radius of curvature formula, you can't solve this problem. Because there is no way you'll get the radius if I give you the equation. These are the two methods you can find radius of curvature. One the mathematical and one using the centripetal thing. Okay, same answer, so it must be right. All clear with this? So there, with this, we are done with circular motion. Now it is your job. You need to finish off your booklet. And then I sent you a sheet last class only. I think it has around 30, 34 questions, I guess. So start solving that, finish it off. I even provided solutions also. But again, I'm telling you, first try the question on your own once. Second time, then you see the solution. Fir bhi samajh mein nahi to get it. The most important thing is you need to put a fight with the question. Again, when you solve questions, don't sit for half an hour for each question, or don't waste so much time. If you're solving a question, maximum do for like 6 to 8 minutes. If the question is tough, questions are easy, maybe 5 to 6 minutes is sufficient. So 6 to 7 minutes. You read the question, try to do, understand. Nahi aaya na, chhod do, go to the next one. Next day, again try for another 6 to 7 minutes. The point is that you have to try the question on 2 different days. When you do this, you know what is happening? You are giving 1 day ka time in the middle for your brain to process what is happening. Trust me, most of the times I have observed this. Let's say if you don't get 10 questions, right? You tried seriously for 6 to 7 minutes and you left them. Next day when you try them, out of 10, at least you'll get 3 to 4 on your own again. I don't know whether you notice this thing, next day you're brushing and suddenly it feels, I should have done that. Or maybe while you're traveling in the car or while you're traveling in the train, you can think about the questions which you didn't get. That giving that 1 day gap is very important. Because you will figure out your brain, because you know why? Not because you love physics. Brain does not like when it doesn't get something. Best example, do this with your mom, tomorrow morning or sometime, you tell your mom, I'm going out. Your mom will ask, where? I am going out. Where? See, she will not be happy until you tell where. Because the moment, I'm going out, there's a blank, people don't like it. Brain doesn't like it. If you tell mom, I'm going down so that, I'll be going with a cycle, so and so. Okay, fine. Explanation is done. Same way, your brains are similar. When you learn something and when there's a gap, the brain will try to fill that gap. So you need to give time. But what you guys do, you try the question for 4-5 minutes. Nahi aaya? Chalo, online open karte. YouTube hai na? You open the online ka thing. You see the solution and you get satisfied. Dopamine effect. Acha laga abhi. Aa gaya answer. You didn't get anything. Bullshit. You just copied it from online. Where is your struggle? To kuch kiya hi nahi. And when the same question comes after the exam in 1 week, what will your brain think? Shit, I don't have access for online. How will I see this question? Instead of thinking, how should I solve this question? Your brain is thinking, Arey yaar, I don't remember how to do this. This is happening because you're not training your brain to think. You're training your brain to spoon feed. You're getting, आपको क्या लग रहा है पता है sir, but waste of time sir. चलेगा ना, then don't do too many questions. That's what I'm saying now. What is the point of doing 400 questions by looking at least half of them online? किसको show off कर रहे हो? Who are you trying to show off like I did 400? Or 200, 250? Do only 100 na then, but do them properly na on your own. Put a fight on your own. बोल रहा ना, try each question 6 to 7 minutes. नहीं आया, next day 6 to 7 minutes. फिर भी नहीं आया, मतलब done. You gave your best. Now ask the teacher or discuss with your friends. But you have to try 2 times on 2 different days. Every time you look at the solution online, your brain is losing an opportunity to think. You're teaching your brain all wrong things. Just imagine when you go to the exam, when you see a question and you're not getting the question, what will your brain think? It will think, shit, wish I had had access to online. I could have seen this solution. Because you got habituated. Instead of thinking, yaar, let me think what is this question, how to do, what to do, your brain is thinking, yaar, इसका आंसर ना मुझे याद करना चाहिए था. So please don't do this mistake. Temporarily ना अच्छा लगता है because you're doing a lot of questions, but on the long run you will lose the opportunity to think. That is the reason you'll never get confidence on your own. Chapter पूरा होने के बाद भी, booklet पूरा solve करने के बाद भी, you will feel like यार my chapter is still weak. Again, I'm telling you, you should try at least 2 times on 2 different days. Give 1 day a gap in the middle for your brain to think and figure it out. Don't be in a hurry to see the solution. But 6 to 7 minutes. If you do like 6 to 7 minutes per question, in an hour, you will be able to do at least 9 to 10 questions. In 2 hours, you'll do 20 to 22 questions. Kafi hai. That's a good amount of questions per day, per subject. If you're studying 4 hours, you will solve around 50 questions. Let's say today, if you're studying maths, physics, tomorrow physics, chemistry, then maths, chemistry, maths. 50 questions, 50 questions, 50 questions. 100 questions per week per subject. In a month, you're doing 400. In a year, you're doing 5,000 questions. That's a lot. Keep this in mind, what I'm saying. You have to try, put a fight, and then you always come back. After 2 times, you gave your best. Then discuss karo, friends ke saath, teacher ke saath. Don't look at online. Online is the last option. ठीक है, चलो, with that we'll wrap up for the day. So please start solving circular motion first. We did 31 questions. Revise this first. That is priority 1.